Hi. In this series, where I compare 5G new radio with LTE, this is part 4, and I'm going to look at beam-based operation as a difference between 5G NR and LTE. My name is Srikanth, and I'm with NanoCell Networks. So if I wanted to summarize the whole beam-based process in 5G, I can say that it has provisions to use it right from the first step, which is the synchronization signals, go on to fine-tuning it for the data transmission process, and can involve both TX and RX fine-tuning. Okay? And if I want to draw a comparative note with LTE, LTE has no such procedure outlined and really a limited amount of support, that too appearing well after say release 14 or so. Okay, so let's look at some details. So if we look at the first step that a mobile usually goes through as a part of network entry, the first signals it observes are the synchronization signals. And in 5G, we have made the provision for these to be having a beam oriented operation, and especially when it comes to sort of FR2, which is the millimeter wave kind of frequencies, we have this a very important part of this FR2 process. Okay. Now LTE does not have any such thing like this. And it's very important to have this because in a very sort of coverage constrained situation, if the synchronization signals are not picked up cleanly, then you can't progress further. Okay. So that's the motivation for, you can say, right from the first step. And once you identify a beam with the scope for the mobile also to have some beams, how these beams are formed is a different topic. Combination of analog and digital techniques can be used in this process. And once you identify a beam, implicitly even the process kind of uses this beam-based operation. So which means that not only the synchronization signals involve the beam-based operation, even the random access channel that we use for the timing adjustment and so on uses this beam-based notion. Okay, so those are very different. LTE has no notion of any beam business in both the sync signals and in the RACH process. The next stage involves fine tuning this, because during those initial steps we are just doing something which is common to multiple people, but now things can be done specific with this, let's say, mobile. So in this case we have a very flexible what we call reference signal mechanism, which is CSIRS based, and the ability to beamform them with a lot of configuration potential, and the ability for the other side to measure, report, and that too, you can say, physical layer measurements, which is really what might be needed in the initial stages. Okay, and if you are wondering how come even the mobile has potential beamforming sort of capability which can be fine-tuned, one can see an example of how that could happen, where a combination of using beamforming on the SRS, which leads to the base station selecting the right beam, could involve applying beamforming to the uplink data channels as well. So not just restricted to downlink, but also the potential to use it in the uplink, and with fine-tuned measurements and reference signals. Remember, LTE has some beamforming potential, especially a beam-based approach after release 14, but the measurements framework as well as the ability to do certain fine-grained beams are limited compared to what is there in 5G. And remember that 5G has it from the first step. So to summarize, as compared to LTE, 5G can start the beam-based operation right from the first step, continue it on when it still has something which is applicable to multiple people. Okay, and then slowly move on to, you can say, user specific. Once we identify that we are dealing with a user, and especially when it comes to some specific data, etc., one can really fine tune it so that it can result in good performance for that particular user. Okay. So I hope some differences from LTE, especially with respect to some of these stages where there was no use of beamforming defined and limited as compared to 5G, is, I would say, the real difference in the beam-based operation. So I hope we have been able to convey something useful. Our website is nanocellnetworks.com. Please visit our website for more information. Thank you.